Okay, so we're going to be dealing with a very tough subject, tough concept. People have a lot of difficulties on these. This is a domain of a function. Now, the book will say that the domain of a function is the set of x values such that you have an output. And the set of x values are often regarded as input. So what's going to happen is just keep in mind that you're going to be dealing with situations where you have to worry about x values that might not have an output. Now, the ones you're going to run into in this class the most in business math, often we have what we consider a rational function. Like this is one you're going to see in regards to maybe something like a percent of cleanup, but we're just going to treat this algebraically right now. So what you need to realize is you could typically plug in x values and not have a big problem. If you plug in 90 and you're looking for f of 90, that's just going to be 2 times 90 and 100 minus 90. And the answer to that is going to be, it won't be the most nicest number, but it exists. So f of 90 does exist. You could try with any other number too, maybe even 110. It exists, but the answer is negative. But there's once again nothing wrong with that if we're just looking at this situation from a strictly algebraic point of view and not using it for anything else. The problem you're going to run into is if you try to plug in 100. Now, if you plug in 100, the situation that's going to happen is you're going to get division by 0. You could put that in the calculator and you're going to find out that that's divide by 0. You could put that in the Google Docs and realize it's an error. So this particular number does not have an output because you can't divide by 0. Now, you could go and plug in any other number you want. It's going to have an output. You can even plug in 99.99999. There'll be a number. But 100 is special because 100 makes the denominator 0. So when you talk about the domain of a rational function, it's all x values such that x isn't 100. Now, a popular way of writing this domain is interval notation because that's a great way to vividly show that the domain consists of any x value other than 100. The parentheses here mean you don't include 100 in the domain. So that would be, so the domain of this function is all x that as long as x isn't 100, or everything less than 100 union with everything more than 100. Now that's one example. Another example you're going to see in this class is the situation involving a square root function. We don't do square root functions a whole lot in 1324, but they are quite often in business math, in business cal. It's a great way to express flattening revenue or any other situation where numbers flatten over a period of time. Now, in this particular situation, once again, we could t-chart, we could pick values. 6 will lead to 1. 7 will actually lead to the square root of 2. 5 will lead to 0. Now, when we start getting less than 5, once again, you're going to have a problem because you can't really have the square root of -1 because there's no number out there that's real and can be equal to -1. You'd have to go into imaginary numbers. But in business math, there's no imaginary numbers. So you have to realize that in a square root situation, the domain is x values such that x minus 5 has to be greater than 0. And therefore, x has to be greater than or equal to 5. And then you could express it in interval notation with a bracket, because you have to include 5. That's why you put a bracket. And then you put 5 to infinity. So that would be the domain. Now, what you do need to watch out for are radical functions like this one, where the expression is actually a situation where x is negative and the function associated with the radical is decreasing. So the expression itself has to be greater than 0. But when solving this particular inequality, you subtract 10 from both sides like we've done before with equations. But when you solve the inequality, when you resolve it, what you're also going to realize is that if you pick values less than 10, you're going to get an output. But if you pick values greater than 10, you're going to get a negative, which you can't have. So this is actually going to have a domain of numbers less than 10. And you would express a domain as interval notation. Probably not the most clearest thing I've ever. It's a tough concept, however. It's best really to talk about this with your group and make sure you go over it carefully. So I'll put up some further videos, but make sure you also do your math lab and do any other assignments the teacher gives you. The videos are nice, but nothing is ever better than trying to explain these things to others. If you're struggling to understand the video, I would say talk about the video and talk about what happened and try to explain your own steps. So this is it. Thank you very much.